All right, so let's look at how to find the domain and range using a graph. So we're going to let y equal f of x. Then the domain of f is the set of x values. So this is our independent variable. And we're going to start with the smallest value of x and go to the greatest value of x that our function will use. So when you look at the graph, you want to look at it going from left to right. And the range of f is a set of y values, so our dependent variable. And we're going to start with the lowest value of y and go to the highest value of y. So you want to go from bottom to top. All right, so let's take a look at this. We're going to introduce interval notation. It's a little bit different. You're welcome. There's several different ways of writing these out. As long as you're communicating it effectively, that's fine. So I want to show you another way that this is presented. All right, so the domain on number 4, if I start on the left-hand side, I go until I reach my function. So here's where my function starts, and I notice that it has an arrow on the end of the line. That means this function keeps going, going, going. If there's no arrow, it means the function stops there. So here the function keeps going, going, going. So it's going to use up all of the negative x values. So I go negative infinity. And as I go from left to right, I see, okay, we're using all of those negatives, and we switch to positives. And then I run into another arrow at the end of the line. And so it's going to keep going to infinity. So my domain is negative infinity to positive infinity. So all real numbers. And another way of writing that would just be to write the capital letter R with the extra bar on the back edge. And that represents all real numbers. So these two things are equivalent. And then the range, we start at the bottom end of the graph. So I don't see my function until I hit here. So here's where my function starts at. Starts at -4. And because we are including -4, it gets a square bracket. If we were not including the point, so for example, where there's a hollow dot down here, we wouldn't include that point. So we would use that rounded parentheses. But if we're including it, it gets a square bracket. And then so start here, I see it's using up all the rest of those negatives. So -3, -2, -1, 0. Then we switch to positive y values. And we see that there are arrows there. So this is going to go on to y is positive infinity. Okay, and infinity symbols always get that rounded parentheses. All right. So there's our range. And another way of writing this, similar to how we were writing it on the first page when we were looking at the practical stuff, would be to say y is greater than or equal to -4. Okay, so this square bracket is the same as saying less than or equal to or greater than or equal to. So it's got that equal to piece in it. All right, let's take a look at number 5. So the domain, if I start on the left, as I approach here, the first place I see my function pick up is here at x is -2. We are going to include that. And it goes, so I see -2, -1, 0, 1. So it's continuous. It's including all of those x values here until I reach 2. Okay, so another way of writing that would be -2 less than or equal to x less than or equal to +2. Right, and then the range. I start at the bottom of the graph and work my way up until I find my function. Looks like it starts here at -4. Write that down. And then as I go up, it includes -3 all the way up to -2. So we finish at -2. That would be -4 less than or equal to y less than or equal to -2. So if you write your domain and range, so just make sure you're getting the right variable in there. I'm going to let you do 6, 7, and 9. I want to do 8 with you really quick, and then I'll have you pause the video and give those a try. So here's number 8. So again, for the domain, I start on the left-hand side. And as I approach, I see that I have an arrow at the end of the line. So this is going to keep going. It starts at -infinity. Right? As I head to the right, I see I'm picking up a lot of negative values. And then my function appears to drop off right as it approaches x equals 0. So it's never going to include x equals 0. There's an asymptote here. So on one side, the function drops off really steep. And on this side, the function goes up really steep. So I'll say -infinity to 0. And since I'm not including 0, it gets that rounded parentheses. And then as I keep going to the right, I see that it starts again just on the other side of 0. So I'll use that rounded parentheses 0, and then my function is going to infinity here. All right, so there's that. Another way of writing that, I'm going to show you that on the range. If I start at the bottom of my graph, I see the arrow on my line, which means it's going to go to negative infinity. So I start at negative infinity, I see my function, and then there's nothing for the function at 0, so it stops just short of 0, and then it picks up on the other side of 0 and also keeps going to infinity. So the range is going to be this exact same thing, and another way of writing that would be to say all real numbers except x cannot equal 0. Okay? So either one of those would be totally fine, and I would like you to go ahead and pause the video, give this a try, and we'll come back and take a look at those. All right, so let's see if we came to the same conclusion. So in the domain here, if I had from left to right, looks like I start at -2. And I'm picking up everything after -2 until I hit +4. And then for the range, I start at the bottom of the graph. It looks like I start here at -4. And as I go up, now this sometimes throws students for a loop because they're like, well, this side ended and this side keeps going. So it doesn't matter as long as one side keeps going. So another way of looking at the range is to think that you're taking this function and you're just squishing it onto the y-axis. So in other words, I'm pushing these pieces here and these ones this way. Okay, and so what that means then is all of those things that got pushed into the y-axis, that is your range. So our range starts at -4 and goes up to +4 here and includes +4. All right, number 7, my domain, if I start on the left, say start at 0. And my function as I head to the right, looks like it keeps going to infinity, so 0 to infinity. And then for the range, I start at the bottom of the graph, work my way up. So again, it looks like I'm starting at 0. And then as I go up, I see the arrow on the end of that function line here. And even though it's going to grow really slowly, it is going to keep growing and it will include all of those y values. So we'll go to infinity. All right, and the last one, number 9. So my domain, again, I start on the left and work my way to the right. So that looks like I start at -4. And I have -4, -3, -2, 1, 0, 1, 2, 3, all the way out to 5. And then it looks like 5 is where my function stops. My range, I start at the bottom and work my way up. The first place I encounter my function is at y equals -2. And I have -2 through -1 through 0, all the way up through 1. All right, so there is the domain and range for 4 through 9. And come back to the next video, we're going to take a look at these ones 10 through 12 that look a little bit different.